Okay, welcome again. A little noisy because I have obviously an engine running. Now I put a clamp meter. This will measure the output in current of this alternator. What you're seeing over here is the current. 45 amps DC. That's with the blower motor on, with the radio on, with the lights on. The voltage, and I had to hold the camera for this one, I had no choice. 14 volts DC at the amps. Now let's crank it a little. Pretty good. Now, what I wanted to show you was the output or the current of the alternator will go down as I put down the accessories. Watch. Now we're back. Now notice the big difference. Before we had 44, now we have 22 amps that the alternator is supplying to the accessories and the battery. Before I had the headlights on, I had the blower motor, which takes a lot of current, and the radio cranked up. That's why it was 44 amps. This test tells me the computer is responding to the request. The alternator is responding to the computer's request, and that's why you're getting more current. As I turn off those accessories, as you see, less load was on the alternator. The computer detected that. It turns on and off the alternator to give less field current. There's a rotor and a stator. It turns it on and off to give less current. This means to me the computer is working, the alternator is working to the computer. They're both communicating. The regulator is working because I have here 14 volts. As I crank it, it should stay the same. Stays the same. But the current, what will change? The current will change based on the accessories. That's one of the tests, how I test the alternator. Obviously I'm going to put a scope on it and show you firsthand. This is the test that I do. Put a clamp meter around that B+ wire. Okay? This is the meter I've been using all along. Please subscribe to my channel. I know it's noisy and photography wasn't that great, but Joe, Electronics Schematic Auto, the other one